Give them a couple minutes. They should have plenty of time. And we got those other two talks done, so we don't need to backfill it. What just happened?
He just went to the wrong room.
Oh, yeah. Well, I got in here and Sue Harris was getting all set up for her working group. So we both had to look at our calendar, and she was in the right room. I knew I was in the right room.
Right.
Because we were here before.
Right.
Oh, well, and also our minute taker has just arrived.
Yes.
So we
Just in time.
So we need to give her time to set up.
Yeah.
Where either gate crashing is dinner, which we have not informed the people being gate crashing, and therefore has a low chance of success, or we're going to detect them.
So we're going to get started in a couple of minutes. We'll let our minute taker get set up, and I think we're still missing the presenter. Mark Smith, are you in the room? No? I guess it's this session between us and Bear, so.
What did you say, Bill?
I just heard Bill. Nothing else.
Yeah. I'm sure we can find a stand-in who will. I can swap the order. Who else are the authors on Mark's draft?
Is there another one?
Yeah.
Well,
Yeah, there's a few.
He's presenting.
Expect people to announce their names when they get to the microphone.
All right. You want to sit down? But you can kick them buttons. Yeah, I'll call them the names.
Well, actually, I think it's just, they're taking names. But still.
And Barbara can recognize all our voices already. Or almost. Or the exactly.
I'm tired. Is it Thursday afternoon? Is that the problem? Yes. Well, this is going to be a whole no fun if you didn't show up. It's unlikely. You think anyone is still awake?
I would not object to somebody else joining me on minutes.
Okay.
You know, helping out just a little bit. It's hard getting everything in.
Yeah. So Shuping, are you in the room?
Yes.
Excellent. Doing Jabra again. Thank you. If someone else want to join in and help Barbara on the Etherpad for minutes, that would be fun. Thank you, Eric. There will be eternal gratefulness dished out. No. Yes, if anyone have the phone number for Mr. Smith, then give him a little nudge, would be nice. Otherwise, I think we will have to swap the order of the presentations.
Wait till 4.
Yeah, I mean, we have some buffer at the end here. We'll be all right. If you want to sing something, Suresh, yes. So, so our esteemed AD is now going to come up and sing a song from Bollywood. You know, he has in his early years. send him an email.
Oh, yeah. We just talked to him about it at the end of the last session. What happened? Thank you. Right, good enough. Not there. Second? Yes, that's it, right?
Run faster. We are waiting for you, Mark.
Nope, 5 minutes ago. Thank you.
Right, sorry about that.
Okay, so welcome to the second six-man session. We now got the presenter for the first presentation on extension headers. Darren is doing the other one, and then the plan was to hold questions until the end of the two sessions. We can have clarifying sessions after Mark's talk and Darren's, but then we can have a general discussion on the topic afterwards. Super, Mark, if you caught your breath, please.
Well, I'm presenting again later tonight, so I was just finishing that one off. Okay, in-flight IPv6 header extension insertion considered harmful. RFCs 1883 and 2460 say this about processing of extension headers. With one exception, extension headers are not examined or processed by any node along a packet's delivery path until the packet reaches a node identified in the destination address field of the IPv6 header. The exception is the hop-by-hop options header, which carries information which can be examined and processed by every node along a packet's delivery path. The hop-by-hop options header must immediately follow the IPv6 header. Its presence is indicated by the value 0 in the next header field. RFC 8200 updated this and made it a bit more explicit. Extension headers are not processed, inserted, or deleted by any node along a packet's delivery path until the packet reaches the destination address. And the hop-by-hop options text was modified in a similar way. The other difference is it says it's may be examined or processed rather than must be. The changes and motivations, well, with regards to the hop-by-hop header, it was found that high-speed routers were ignoring the requirement of must process. So that was loosened. Sorry, it's all right. The other one was triggered by a draft around the time of 8200. It's an example in this. It's related to the Spring work, but I'm pretty sure there's been a few other internet drafts. And that's why there was some clarifications about what processing involved. One thing to remember about RFC 8200 is actually one of the 92 full internet standards, and there's billions of implementations, and there's probably 100 in this room. So the purpose of this internet draft was really to capture the and record the reasons and motivations for the 1883, 2460 and 8200 text, and also to describe an IPv6 architecturally compliant solution. To define in-flight EH insertion, we've got a packet going from the left to the right, or from A to C. It's transiting network B, and network B on ingress is inserting an extension header. And then at egress of B, hopefully the extension header is removed so that the original packet arrives at C. Some observations: the original source and destination address of the packet are not modified during insertion and removal, and they couldn't be. The packets are being modified without attribution, so it's an anonymous modification. The packet size got larger, and an immutable next header field got modified as well. The motivation, this particular draft hasn't really said why it wants to do insertion. My speculation is that because there's 128-bit segment routing IDs, the same size as IPv6 addresses, it's going to add quite a lot of overhead. And so perhaps the idea is to try and save overhead somewhere else instead of having smaller SIDs. One quote which has been removed, I think Darren posted version 8 of this, but and this is an example of text we might want to look for rather than being specifically one that's continued. There's some theory in the draft. Since the SRH inserted within a intermediate node must be removed when all segments within the SRH have been visited, it is not possible to leak the SRH to the destination outside the source domain. Unfortunately, that's a theoretical statement rather than a practical one. I've experienced all three of these things in my career: implementation bugs, partial device failures, and device misconfiguration. So that sort of master assertion in a internet draft or an RFC is really an aspiration. It's not an assurance. It may not be removed. The other thing to observe or be aware of is that these sorts of boundary devices, and while a firewall is not quite the same, it's quite common to have only a single instance of them. I have actually heard of somebody having 2 NAT devices in a row. Surprisingly, it was at their home and they were some information security person from EY or something. But most of the time, in my experience, there's only been a single edge device performing these sorts of function. So that means there's really only one opportunity to perform this operation. And if the operation isn't performed, then the packet just keeps going without the changes that it's supposed to have. So we have a single point of failure on the boundary. This is a scenario, and this is sort of where my objection comes from. We have a scenario where a packet's traveling across the internet from a source AS on the left right through the destination AS on the right. The source AS might be, say, a video content provider. The destination AS on the other end is a residential ISP, and I've spent quite a lot of time at those. As our packet goes across the internet, it traverses a number of ASs, and AS1 has chosen to do anonymous EH insertion. For some reason or other, they failed to remove their inserted EH. Because the destination address of the packet hasn't changed, the packet will just keep going to the destination AS. And the brokenness would occur at the destination AS. The question then, as me as an operator sitting there looking at these packets that may be taking 5,000 or 10,000 of my customers' video content offline, is who inserted the EH. There's nothing in the packet that tells me that. And therefore, I will have to manually or go and brute force contact every single AS, ask that AS, are you inserting EHs? Ask them, are you removing them? And they'll say, no, my vendor writes perfect code. And I'll say, can you have a look, please? It may even involve, you know, disconnecting 100 gig links to try and insert some sort of device to you know, capture the packets to determine that the device is really performing as it's supposed to be. The problem is that this fault is only really seen as after the packets left the network. So most operators, and I've certainly been one of them, if you like, I've never inspected the packets leaving my network to see if they're good or not. You know, once they're gone, once the traffic's there, they're gone. So the consequences and impacts, the sort of fundamental thing is it's ignoring the source address field semantics. The packet has now got, in effect, 2 devices that have constructed the packet, but only one of them is identified by the source address. And this means that in this case, if the EH triggers some sort of mechanism that relies on the source address of the packet, it's not going to work because it can't, the EH device, the EH inserting device hasn't been identified. The classic case would be ICMP v6. So if the EH triggers an ICMP mechanism of some sort, it will, the device that sends the ICMP v6 message can only ever send it back to the source address of the packet. Well, that's not the device that inserted the EH. So it's not going to make it to a device that can solve the issue. A specific case is ICMP v6 PMTUD. The packet size has got bigger because of the inserted EH. If that triggers a packet too big message, it can't and won't be sent to the EH inserting device because that's not identified. It'll also potentially break IPsec or IPsec. If it's not removed when it arrives, it'll look like unauthorized modification of the packet. Another possibility, in my diagram, I only had one transit network inserting EHs, but imagine if one of those other ones was as well. If the first AS didn't remove the EH and it kept floating along to a later transit network, and that later transit network was also using EH insertion, then the EH might get inside that network and impact operation some other way. Incorrect destination host processing. So one of the issues is that this EH that was inserted was not intended to be received by the device with the destination address. And how an unknown EH is handled is indicated by the top 2 bits in the type of the EH. This could result in a packet that gets discarded, even though it would actually be possible to skip over the unknown option and process the remainder of the packet. The opposite could occur as well. So a packet could get, I've actually lost which order I did it, but anyway, the packet could get processed when it should really be discarded based on the context of the video. So, you know, the application that's in the payload or packet. Implementation complexity. If you think about it, the edge device, on egress, has to scan the EH chain, assuming it's possibly not the first one, to determine whether there's an EH there to remove or not. This is more complex than using a simple destination address match. And the destination address says to a device or says to a router, should this be forwarded further using simple forwarding, or should more deeper processing of the packet occur? Finally, I think it's even as fundamental as Postel's law of robustness principle, which says be conservative in what you send, be liberal in what you accept. Inserted EHs are not expected by RFC 8200 compliant receivers, as RFC 8200 prohibits them. So purposely sending them is not being conservative. I think the solution is encapsulation. It's the classic way to add new information to an existing PDU. Obviously, we should all understand and remember the TCP and CAPS application, IP and CAPS TCP, link layer and CAPS IP. To me, the solution is to encapsulate in an IPv6 tunnel. And RFC 2473, the generic packet tunneling over IPv6 spec, actually shows an example of adding new EHs to an existing packet after the new outer IPv6 header. And therefore, RFC 2473 provides EH addition attribution via the outer IPv6 source address. As an example of the benefit, that means that PMTUD works because the tunnel endpoint that increased the packet size is identified by the source address in the outer header. There's a really good internet draft that's been in development for quite a while that expands much more on tunnels in the internet architecture. I think from memory it's 20 or 30 pages, so it's quite a big read, but very comprehensive. 50, yeah, okay. It's very good. One of the issues which seems to be a possible motivation is to try and reduce tunneling overhead. One of the struggles I remember dealing with, because I've done quite a lot of work in the past with IPsec tunnels, is this idea that there's an IP packet inside of another IP packet. And it's sometimes a bit of a struggle to sort of forget that the payload of the outer packet is a IPv6 packet in itself. So in that context, if we forget about, or we just look at the model, in a common IPv6 packet, there's a link layer header on the front, Ethernet, PUP, etc. In an IPv6 and IPv6 tunnel, it's the same thing. It just happens to be another IPv6 header, and it's coincidence that the fields and the semantics have the same meaning. So if we consider and remember that an IP tunnel is a link layer link, then we can use link layer compression to compress the inner packet. An example would be robust header compression. So you would apply this on the inner packet's IPv6 header and possibly other headers on the inner packet to compress the effective size of the total. Something else that I worked on a few years back, just as an idea sort of triggered by this, was what I've called skinny IPv6 and IPv6 tunneling. So this actually leverages the fact that the inner packet and the outer packet have the same header and same header semantics. And so what it does is, for nearly all of the fields, it basically makes the outer header carry many of the inner fields' values, and then disposes of nearly all of the inner packet header effectively, and then reconstructs it at the other end. Another thing it does is uses /64s to identify tunnel endpoints rather than /128s. And the unused IID parts of the outer IPv6 header address fields copy and carry the inner packets IID fields. One of the emergent advantages of this is that the actual the tunnel packets will actually be spread via ECMP, because they become inputs into the ECMP load sharing. So that was just an idea, another way of possibly reducing the tunneling overhead. All right, thoughts and questions? Oh, hang on, we're doing that later.
Well, we can do, if there's any clarifying questions, we can do them now.
Okay. Yeah, I have a clarifying question. First part of it, did you read draft foyer number 7? That was the one that was published in September.
I did,
Okay.
and yeah, sorry.
Okay, and then how are the slides that you just presented about in-flight extension header slide, the very first one, and your single point of failure slide related in any way to what that draft describes?
So what that draft does is it's actually inserting into the tunnel packets.
Right. So the packets that are already encapsulated for their journey within the SR domain.
Yeah.
So the stuff that you were discussing about how a packet that you're sending over the internet might have extension headers inserted between domains, I mean, that's not relevant, is it?
Look, to some extent, as I said in this this is to capture the broader issue.
I see.
So if
Could you elaborate on what parts of your presentation were relevant to the draft versus which were in general?
Perhaps, Darren, if you present
Okay. We'll be able to
yours, and then, perhaps we should allow for a few minutes of, you two debating it, and we can.
Okay, all right, sounds good.
we can watch and eat popcorn. Super, thank you.
Thank you. Bring this up a little bit. There we go. Okay. No, I don't have to slouch. Okay, so this presentation is, of course, about segment routing header insertion within an SR domain. Okay. There's been several versions of this draft. I'll just quickly mention the one that we'll be talking about a couple today. I just updated the draft yesterday and sent out the mail today. So, we'll of course talk about revision 7, which is a very important revision. But we've made some changes in the most recent one, and we'll go over those too. But I think it still leaves all of this discussion entirely relevant. So we can discuss all the versions of the draft. In revision 7, we made the draft standards tract. We added a lot of normative text to describe how segment routing header insertion in particular is done within an SR domain. We described the insertion process. We described the removal process. We described ICMPv6 processing, path MTU discovery, and went into, I think, a lot of good detail on how implementations can do segment routing header insertion within an SR domain and do it safely within that domain in order to provide different types of services within the domain. In revision 8, we've gone a bit different way. In revision 7 and prior to revision 7, there was a lot of discussion, like the first part of Mark's slide, where it was kind of thou shalt not do segment routing header insertion because 25 years ago, we wrote some text that said extension headers aren't inserted, modified, or deleted except at a source or destination. And while that was very applicable to the larger internet, we are looking at segment routing header insertion within an SR domain, and that's a much more limited scope. So what we've done in revision 8 is we've described now how deployments and implementations are doing segment routing header insertion, why they're doing it, and documenting the fact that it is done so that this community can understand that this is something that's real, it's happening within limited domains, within SR domains, and get some of the motivation for why that's happening. Okay? But we can still talk about both revisions today. I think it'll be more fun that way. Okay, who's deploying this? We saw some of this morning, so I'll skip over it quickly. SoftBank, China Telecom, Iliad, China Unicom, Cernet, MTN Uganda are all deploying SRv6 and with SR insertion within their domains. Who's supporting SRH insertion and removal in their implementations? You guys have seen this in previous presentations in 6-man. I'll highlight custom ASICs from Cisco, Huawei, Merchant Silicon, Broadcom, Marvell, Intel are supporting the insertion and removal capability, and some open source content. So one thing that's important for us to remember is that SR domains encapsulate the traffic that's traversing them. We had a lot of discussion over the last couple of years that I've been involved in this working group on that with regards to the SR header draft that's now nearly RFC'd. And we do encapsulate the packets that are traversing the domain always. So packets that are traversing it or packets destined to nodes within the domain or packets from within the domain, exiting the domain are always encapsulated. So in other words, all the packet headers within the domain have a source and destination address that are for nodes within the SR domain. So the SR domain is protected in that devices outside the SR domain don't get access to those SIDs within the SR domain. And we've said this in the SR header draft, soon to be RFC, about how that domain is protected. And I'll go through how the implementations and deployments actually do that protection. So let's remember that domain encapsulates everything. So packets going from node 1 to node 2, when they traverse the domain, they get encapsulated in outer IP header. Packets going from 1 to 5 would also be encapsulated for the journey within the domain between 3 and 5. So we'll reiterate that.
Sorry,
And
just a clarifying question, could you just, the two of you are using like different styles here, so could you just explain what the dots and the numbers and stuff mean
okay.
here?
So in this diagram, this is out of the draft. So who's read the draft in any of the versions? All right, lots of people. Oh, awesome. Okay, so and this is similar to the SR header draft as well. It uses the same thing. So node 1 is connected to node 3, 3 to 5, 5 to 6, 6 to 4, and 4 to 2. Okay. Nodes 3, 5, 7, 8, 6, and 4 are all within the SR domain. Node 3 and 4s are essentially PEs of the SR domain, ingress, egress PEs for packets heading from left to right. Sound good? 7 and 8 are other nodes within the SR domain. All right, they're also 7 is attached to 5, 7 is attached to 8, 8 to 6. Okay, okay. I'm giving it as an example that there's a some network that has some edge nodes, and nodes outside of it connect to those edge nodes, and traffic that traverses the SR domain gets encapsulated.
And the like 3 does the encapsulation, assuming it's going.
That's right. Yeah. So let me clarify that as well. For a packet from node 1 to node 2, node 3 receives that packet. Node 3 encapsulates in an IPv6 header between node 3 and 4. Okay. The source of the packet, the outer IP header, is node 3. The destination of that outer IP header is a SID at node 4, and that packet traverses node 5, 6, 7, 8, etc. Well, depending on its path, hopefully not all of them. So what operators have done, for example, and this isn't specific to any one of the operators, this is in general, they make a choice as to how they define SIDs within their domains. So for example, an operator with a GUA block of /28, PPP, PP something /28, would use their block to sub-allocate a block of SIDS. So PPP:B, where B is the block of SIDS with a, let's say, a /40. Okay. And within that block of SIDS, so that /40 identifies all the SIDS within that SR domain. Within that block of 40, there's, let's say, a /64.
Darren, Andrew here from Liquid. I just want to ask a clarifying question, because you refer here multiple times to a SR domain, right? Can you clarify exactly what you mean by an
Yeah, please
SR
read the
domain?
drafts. Thanks. Okay. So again, we allocate a /64 SID locator to each of the nodes in the domain where that prefix is, for example, PB4, for example, at node 4. So node 4 receives for example, a /64 from which it can allocate segment IDs for use at that node. So anyone familiar with our SR header document should remember that those SIDs are then used for different things. Who's familiar with SRv6 network programming? Who's read that, looked at it? Okay, good. All right, so the majority of the room then is also familiar with the fact that different SIDs are allocated at those, excuse me, allocated at those nodes. Oops, okay, here we go. And we do have experience in automating this process of course, block allocations to nodes. Okay, so I guess the user error in that area is pretty low. The next part is then in how we protect the SR domain. And if you'll remember, the SR header draft defines how we filter external traffic entering the domain. And at the ingress edge, we apply an ingress ACL that drops any packets destined to that SID block within the SR domain. And then on internal nodes, we also filter traffic destined to the local SID block from any source address that is not within the SR domain. So we protect who is able to access those SIDs and use those SIDs. And again, we have experience automating that process as well. So the chances of user configuration error are very low. So within this SR domain, what these operators provide is a VPN service that that I described previously, essentially. So there's an ingress PE at node 3 and egress PE at node 4, and the ingress PE performs that IPv6 encapsulation with a SID that will decapsulate that outer IPv6 header when the packet reaches node 4. Now that SID might be an n.dx or n.dt SID. For those who don't know, those simply say forward the inner packet on a adjacency or forward the inner packet based on a lookup in a particular v4 or v6 table. Within this SR domain, providing a layer 3 VPN service, there's a feature called TILFA. TILFA provides a less than 50 millisecond link and node protection for traffic traversing that domain. And remember, that traffic is all source and destined to nodes in the domain. For that TILFA traffic, we are going to be performing SR header insertion. Yeah, go ahead. You have a question?
Yes. So you give
Name,
very
please.
Greg Mirsky, ZT. You give very specific time. So is it switchover for one tunnel or switchover for some number of tunnels?
Okay, so that's more of a feature thing, I guess. So in the products that I'm aware of, for any traffic destined via a node or a link that fails, the repair path is pre-computed for that traffic. And that point of local repair inserts an SR header to get around that link or node failure to the destination. So where I say a 50 millisecond or sub 50 millisecond packet loss, that's the implementation at that point of local repair that's pre-computed this repair path that inserts the SR header that then sends everything that's that's via the linker node that's failed over that pre-computed path.
Okay,
Okay.
but you can have off this edge of the segment. So your next segment can be several IP hops away.
Yeah, and
So
and
how
that's
do you know that that tunnel has failed? And you need to route not around
okay,
your
so
link.
at this point in the middle of the SR domain, I don't care if this traffic is tunneled. I don't care that it is tunneled traffic. All I care about is that this traffic is destined to a node that I have protection for. I protect traffic destined to any node in the network with a pre-computed path that is going to get me around any linker node failure for which I am the point of local repair. If you want, you can read the TILFA draft, and that one's got a lot of detail on how this actually works. But for the purpose of this presentation, let's take it for fact that
No.
these
Let's
nodes
not take it.
insert an SR header.
No.
Because otherwise, I'll get you to sit down. I'll finish this one, and then we'll come back to what it is that you're asking. Because I'll ask you: is it related in any way to SR insertion within an SR domain,
well,
or are you interested in how TILFA works?
no. You give specific number and you don't explain how you arrive to this number.
Okay, it's an implementation specific thing, as a feature of the products that are listed and used in that domain. So
Okay.
that's the specific number. Thanks. Okay, so let's go over where does SR header insertion occur. It occurs at any node within the SR domain. Okay, and that's any node that's at point of local repair. So in this case, where we're doing TILFA, a node that is a point of local repair running supporting TILFA is going to insert that SR header. Okay, that assertion occurs on the outer IPv6 header, which is the one that essentially tunnel header between the node 3 and node 4 within the domain. The SR header removal occurs at the destination address in the outer header. So that SR header gets inserted and it's removed at a node that the inserting node decided on when it inserted the SR header. So that destination node in the packet receives it. In the terms of network programming, he pops, he does a penultimate segment pop, and removes the SR header that was previously inserted, and the packet continues on its journey to the destination node within the domain.
So Darren, could I ask a
Yeah.
clarifying question? So are you saying that node 3 would not insert or that packet from node number 3 would not have an SRH header?
Well, in the layer 3 VPN example,
Yeah.
There's no need for the SRH header because it is just encapsulating with an end.dx or DT SID. If there were traffic engineering also applied, well then yes, you could have an SR header.
But
That
since
would
you're
be-
saying SID, would it not, how would you, if you have a packet with a SID, do you have to have an SRH header as well, right?
Do you?
Well,
No.
I'm asking.
No, you don't. No, the answer is you don't, because if I simply encapsulate an outer IP where the destination address of that IP, that outer IP is an SRv6 SID, and that SRv6 SID's behavior is to decapsulate the packet, then we will decaps. And I think that is actually
okay.
described in the SR header draft as well.
Bertie, also clarifying
Hey, Bertie.
question. Isn't it, I mean, you're saying just the EH is removed, but isn't it the whole outer header that's removed? Because that's the destination node. So it's not really removal, it's just sort of taking the,
Well, it depends. So if that if the node that receives this packet with the inserted SR header is node 4, and the SID is the decapsulate SID, then of course that entire IP header is removed.
okay.
If the node that receives that packet is another node prior to node 4 in the example, then the removal would happen at a node before node 4. Okay, it's up to the node that inserted the header to also specify what the SID is that's going to remove the header. Okay, and that was described in revision 7 of the draft in more detail.
I got a question.
Yes, you can. Go ahead.
It's from Sri Hari. And the question is, when SRH is inserted at PLR, will the SA be changed to PLR node?
No, it's not.
If it is not changed, and if there is a problem along the backup path that requires SMP v6 packet generation, where does ICMP v6 packet reach?
In the example, it would be sent to node 3, and node 3 would process the ICMP error.
Since SA is not changed, will it reach the PLR or original source node?
It'll reach the original source node, node 3.
Okay.
Thanks.
Darren, I want to ask
Andrew?
bit of a clarification. Yeah, it's Andrew here. Bit of a clarification, and if it is in some RFC, please tell me where so that I can go and read it. So you say that on the backup and on the protection, it inserts a header. Now, in an SR domain that potentially spans 10,000 kilometers, 15 countries, thousands of links, I want to clarify what happens if I get a break here, and then I get a break there, and then I get a break there, and I get a break there, and I'm now running 6 breaks deep.
Okay.
Am I ending up with 6 header insertions and very, very large stacks as a result, or not? I
So
don't quite understand that.
Yeah, so I'll suggest that you read the TILFA draft and the way that post-convergence path is computed. I can send you to the link to that later, Andrew. Thanks.
Mark
Mark.
Smith.
Mhm.
Hey, we haven't organised the CMO seats yet. have
Hey,
we?
no, shh.
Can you go back to the diagram?
Okay.
Sorry.
Is that good enough?
Well, yeah, that's enough.
All right.
So the approach I would take is that I would make 3 and 5 tunnel endpoints, and then 5 and 6 tunnel endpoints, and then 6 and 4 tunnel endpoints. And those are then the opportunities where you can add or insert or remove your SRH.
Okay.
And then that gives you the attribution, the source address update, and so on. So
Okay. Yeah. Let's hold on to that, and let's not forget that you said that. Okay.
Yeah, Cheng Li from Huawei. And I think the SRH can be inserted within the SRv6 domain, and it will be removed within the SRv6 domain. So I think
That's right.
it's secure. It's secure.
Yeah, and I think that's what I was trying to point out during
Yes.
Mark's presentation,
And
is that it doesn't escape.
As my understanding, the maximum SRH number would be 2, but we can make it numbers, but we don't need to do that. Yes.
Yeah. So yeah, there's some math and some research that's also in the TILFA draft saying what the kind of typical or maximum sizes would be for those inserted SIDs. Yeah.
Yeah. So I think this is a good idea. Thank you.
Okay. The draft does talk about MTU planning. 7 and 8 both talk about it. MTUs at the ingress nodes are of course less than MTU in the domain itself. This is pretty standard operational procedure. Joel, do you want to wait 1 minute?
I can wait 1 minute while
Okay.
you finish your last slide.
All right.
Thank you.
So we've seen from the beginning, it's deployed, it's functional, there's vendors doing it. The purpose of revision 8 is to state that fact and let the community understand what's going on and what's happening, and understand that this is a fact and it is what's being done within SR domains. We do expect this to happen a lot more over the next few months, and of course over the coming years. So this situation of SR header insertion within an SR domain isn't going to stop regardless of the outcome of this discussion. Go ahead, Joel.
Okay, let me just comment on your last point. Saying we're going to violate the RFC no matter what you do is a bad reason to ask us to change the RFC. Please don't. Now, let's back up. The thing I didn't hear in this whole thing was any explanation for why, other than saving a few bytes, you need to do insertion instead of encapsulation for this TILFA problem. We know how to, I'm not arguing that one shouldn't do TILFA. I have read the TILFA drafts. They do work really
you do have
nicely.
options. You do have options to do encapsulation and implementation. I'm
So
saying that
why
there's
should we
also the
change-
capability of doing the header insertion within the SR domain, where that is a limited domain, or you can ensure that this insertion is going to be
But
is
Darren,
not going to escape the domain.
that
And
doesn't
that
answer
is the
the
answer,
question
Joel.
I
But that
asked.
is the answer.
The answer is you wanted to. That's not a good answer.
So I think we now have moved away from clarifying questions to the actual debate.
And I've got to say that both Mark and I were very upset that you did not tell us that there was going to be a debate, because if you did, we would have arranged some sumo suits, and we could have, like, it would have been spectacular.
So we're trying to make sure, yeah.
We'll plan that for the next.
Okay, good. The next debate.
I don't think this is going to be done tonight.
So, Suresh Krishnan as AD, Joel, to respond to one point, right? Like from version 7 to version 8, the draft has been changed to informational. So they're not seeking to change the standard. Okay. No, I'm just saying, right? So now it's like really like a documentation of some like implementation and deployment rather than trying to change it. So for me, that changes something in my brain. Okay. It's a different thing. So I do understand your point, but that's not what Darren is proposing today.
Okay. So since we're in the debate portion of the event today,
So
I'm going to take the mic.
Hold on to the mic. Mark is also coming up, and people can come to the line and ask questions.
So
and
we're
you
going
can
to shake hands.
answer as appropriate.
Okay, look at that.
How well do you sing?
Yeah. Well, and to your question before, it's like, it is a debate. It's not wrestling,
Yeah, okay. Oh.
I think.
Well, this is, I don't know. Okay, since I was at the first person to get up to the mic, I'm going to kick off the questions. So just a second.
I got two. So first one is.
Okay, hold on, Shupeng.
No, actually, let's do we know you can talk to each other, but we would like to hear from the people
Okay.
at the mic.
Oh, she's got a jabber comment.
No, I understand. That's fine.
Yeah, go ahead with a jabber comment, right?
Yeah.
That's where we're going. Okay.
So the first one is still from Thresh Hari, and it's a follow-up question to SA. It's not updated at PLR. And if there is an issue with MTU, what is expected by Node 3 when it tries to send the packet again?
Yeah, revision 7 of the draft describes that. Thanks.
Another one from Zheng Qiangli. It's a clarification question. I just want to make sure that the operators you mentioned deployed SRH insertion, not purely SRH. If so, could you please add the SRH insertion scenarios in the deployment draft?
Okay, I'm gonna say yes. I'll listen to recording. I'm not sure what was asked, but I'll listen to it and I'll try to answer that.
Eric Klein. I'm not a router implementer, and I
Okay.
did not follow the SRH development. So this is just a hypothetical question. If the SRH header was say large enough and had padding at the end, is it computationally the same or more expensive to say rewrite the SRH to sort of insert your stuff at the top rather than insert?
I see.
the whole
So
header?
when
Because
so
we're a
that's
scratch space.
Yeah, so it's really going to depend on the hardware implementation as to whether that, you can, how well they're able to kind of do the split versus the just right into. I would say that's very implementation specific.
Because given that you're having to take MTU sizing considerations into effect in this network, in the SR domain anyway, you could sort of like maximally pad it at insertion and just allow endless scribbling over it all the way until you got to the end. But I'm not, like I said, I'm not a router implementer.
Yeah, I
so
mean, the
don't know.
TLVs can be changeable based on
The
the spec.
TLVs can change it in the header. Yeah, I understand what you're saying. We didn't go that way. I don't think we would, but I understand the point.
Eric Nordmark, I actually came up to ask a clarifying question, but I don't think.
You can.
I can. Okay. Well. But in terms of protection, what you described, and I checked the Surrey draft as well, it talks about protecting people from injecting things with this prefix, right?
Yeah.
I assume that people configure it so that prefix doesn't leak as a DA as well out any part of the domain, but that's not written up in the draft.
Yeah, actually, I think Brian had a similar comment. So so I guess it's basically how do you make sure at that egress edge that I'm not sending a packet to something that's not an egress edge? Is that
Yeah,
what
that's
you're
not
saying?
in the /40 prefix, right? That it doesn't go
Yeah, I think-
outside.
Yeah, I think Brian asked that same question on the list, and I think
Okay.
we can address that.
Yeah.
I'd use a ULA prefix for that. Quite seriously.
Yeah. That's one way. There's
implicitly stops-
exactly
yeah.
it does. Another way is, of course, you've got ingress ACLs, throw on an egress ACL. It's another option. Yeah.
Robin from Huawei. I think this is interesting debate. From my point of view, this is just show the confliction of the issue of the network boundary. Yeah, because I think I mentioned some mail. I think that's some way thinking about this the IPv6 based on the internet, but some is based on the limited domain. So I think this because this is a different requirement, we have the different concern. So from our point of view, I think the SIH insertion work. I think this is in the current deployment. You always use from my point of view, the mobile transport or the IP core transport like this one. So I think this concern is raised from the internet. I think it can be controlled. This is the first one.
So some of it. Oh, go on.
Yeah, second one, I think in fact we also comparing the possible this is the choice. I think maybe we also use some of the tunnel method like this one. I think this will introduce the more complexity and the overhead. So I also can reduce this the design, this the simplicity. That is also the concern on this one.
So I think some of this comes down to claiming to follow IPv6, RFC 8200, and then not actually following it. And it might sound like an academic argument, but you're either following it or not. And if SI come up with IPv10, that's a copy of the IPv6 spec, but allows this, and then says we use IPv10.
Yeah. Well, I mean, RFCs are always open to being updated. I think what's highlighted in this discussion, and Brian Carpenter has a draft on this that is not finding a home in 6man, but has a draft on this on unlimited domains.
I'm one of the IC reviewers of that one.
There you go. So he's describing a case where there do exist, and he's recognizing the fact there do exist domains where things other than what are stated for protocols across the internet are applicable. And I think this is one of those cases with the SR header insertion within an SR domain.
So I'm not that surprised that you put like MPLS up there. And one of the things that I've particularly, and you might have seen me quote the RFC 8200 earlier today.
Mm-hmm.
In MPLS, although people,
Go ahead.
in MPLS, although people probably have never done this, imagine you've got two LSRs with an Ethernet link between them.
Mm-hmm. Yeah.
Obviously, everybody would do point-to-point Ethernet these days. But if you inserted an Ethernet switch or bridge in between, that's sort of the equivalent of what an IPv6 router is. So in IPv6, IPv6 routers forward packets for non-local destinations.
Mm-hmm.
A host is anything else. And so in the MPLS model, LSR, like comparatively, LSRs would be IPv6 hosts, and an Ethernet switch would be the equivalent of IPv6 router. And so that's where, when I look at the diagram up there and see those intermediary hops, to me, they're actually IPv6 hosts, or should be. And tunnel endpoints are actually hosts. And therefore, then once you go from one link to another in MPLS,
that's a heck of a convoluted. So basically, you're saying build tunnels between every node.
Yep.
Okay. I would not want to deploy that.
Janko, I'm fascinated in this discussion. And I remember when we had the same discussion when 8200 was written, I can remember, was it you, Shirish? Someone said, we can say we should not modify headers, but if you find the use case and a way to do it safely, we can review the decision, right?
So I'm a bit confused with your presentation and your draft, Mark, because I think it's actually trying to say not what is exactly in the title, because the title says insertion is harmful, but what I see on the slide, you're saying that removing is harmful. Because if you look at your slide and let's say I have a server on the left and the source node generates a packet with extension
Jen's
header.
got a use case she hasn't told us. Well, hasn't told me. She
Yeah,
wants to
I
insert
have
but not
other use
remove.
case. I just didn't want to put more oil in that fire and submit my draft. but-
Understand. And Ollie
So,
has-
Jen and I are going
so
for
answer
beer
my
sleep.
question. So basically, most of your concerns are still applicable if the source node has an extension header. If the packet was generated with that extension header and it was not removed on the fly, right? And the edge of the domain.
So I qualify this because Ollie brought up some examples from IPsec. There's bump in the stack and the bump in the wire. Bump in the stack, I wouldn't consider to be in-flight insertion because the source address in the packet is the source is the device that's inserting.
Yeah.
It may not be at the IP layer, it's happening lower,
Yep.
but in terms of protocols like ICMP, PMQD,
Yeah.
that's all
I think we all agree.
working.
Yeah, but the problem will be the same. If I have a server in data center which generates a packet with SR or any other extension headers, and I expect them to be removed at the edge or never leak, all your problems on your slides are actually the same, right? Because it's not
Probably, I
about
haven't
so
thought
basically
through that,
all those
but-
problems caused are not by the fact that someone on the fly inserts them. It doesn't matter where is this extension
Well,
header coming from.
exactly.
It might be generated originally with the original packet by the sender. It's just the problem is they're not removing it, right?
That if you do read the draft, Mark, that is what you put in section problems with extension header removal. Like that's basically the whole draft talks about, hey, extension header removal can have these problems.
Sure.
And okay.
That's
But those-
the proposals I've seen have always been in-flight insertion and in-flight removal. So
Yeah. So
I haven't
basically,
I haven't seen this. What case Jen's talking about?
Yeah, so basically, I think the document is a bit confusing, yeah, because basically the statements you're making, it's not what I think you're trying to say.
Well, it's all about failing to do something and the consequences of it.
No, I can generate packet with extension headers. That's fine, right? So you're fine with this, right? You just think what is harmful is intermediate node to deal with it.
Yeah, I'd like to see your case before I absolutely understand that, but
Go ahead, Ben.
Okay. Robin again. So I asked the IELTS two comments. The first one, I think we should respect the RFC, but I think this need to be driven by the requirement. Yeah, I think the RFC 8200 proposed many times in the mailing list, but I think the SRv6 is helpful to IPv6. I think this is also propose this is the requirement of the fast reroute, and this is the binding seat. This is also I think the insertion is a simple way to solve this requirement. The first one.
can I call you when I lose
I
50,000
think-
users off my network?
Well, again, this is within an SR domain. It's not within.
But that's sort of the thing.
Second one, I want to say, I emphasize this. I think this we believe in the running code. I think we already say that the INTAC, the Europe, this advanced network tester center already tested the faster SRv6 TRFA. That's between the different vendors. So I think this already, is
So the
used.
thing to keep in mind, and I put it in my slides, this is a more broader IPv6 six-man issue,
Yeah,
while
the-
this is being an example.
So the problem is that with your slides and with your draft is that you are not considering the proposal that's made. The proposal that is made is SR header insertion within an SR domain, and you say extension header insertion on the internet is bad. And you know what? I don't want my phone, wherever it is, when I'm talking to whatever, to have extension headers inserted within the packets that it is generating. It might cause me problems. But if a transit domain happens to encapsulate my packet and do whatever the heck it wants with my packet, I, as an endpoint, am not infected by it. So your examples in your draft, your examples in your slides had unfortunately, no relevance to the question that's being asked.
So I think this comes down to, in your SR domain, are you talking IPv6 or not?
Yes.
So I think let's go to the final phase. I have some conclusions, and I think Suresh does as well. I want to thank you both.
Thank you.
I think this has been quite good.
We didn't come to blows. Thank you, Zan.
No, you
We're going for
didn't.
beer, so I'm sorry.
Yes.
Thanks, Mark.
There's a lot of beer. Thank you very much.
I hope you're all entertained.
So, Suresh, let me go first.
Yeah,
and
go
then-
for it.
So, as someone said earlier, when we were talking about this, when we were doing what became RFC 8200, what was said was, this is the default case. You can't do insertion or modification, whatever was on that slide and in the draft. But if someone can write a document which describes how you would do it and deal with the issues, then that could be considered. And so the first thing I note is that we have discussed this in email quite a lot. So I think it's quite good that Mark has started the process of writing a document that actually writes down the issues. This is, the first version of this draft, and I think it's good. It needs a lot of work, but I think it's good that we're getting these issues written down because it gives, it lays them out. And so if there's a proposal like we've just heard about for SRH insertion, they can say how they address the issues, and then we can consider it rationally as opposed to just endless email. So I think this is quite good. I don't think we're quite done to consider either of these, but I think this is a constructive way of dealing with it, better than just the, gigabytes of email that we did before. So, yeah, well, that's good. That's why we write documents here, is to write these issues down and get agreement on them. And I think both of these things could exist at the same time because they can address each other. And some of the things I heard about, it's just off the top of my head, it seems like doing insertion in a tunneled packet seems less problematic than just doing the general case of insertion, which is what RFC 8200 is really talking about. So I think there's some ground here to work in that is reasonable. So let me go to Suresh.
Yeah, Suresh Krishnan. So, Bob, you covered most of the things I wanted to say. So, like, originally when I threw down this gauntlet kind of thing, right, saying like, okay, explain how this works on the internet, I don't think that bar has been met. So, like, I agree with a lot of the problems that, like, Mark brought up in his presentation. And I contend they're not relevant in the stuff that Darren talked about, right? And so if somebody comes to me and says, like, hey, this is Darren's draft, let's go change 8200, I'm going to say, hell no, right? But I don't think that's the ask. And the ask has changed in the draft, okay, from version 7 to version 8. So that's kind of like, we are not past the emotional stage, like to look at that. So I think the ask is completely different than before. And I'm way more comfortable with like version 8 talking about experiences and deployments rather than saying like, hey, let's go relax 8200, because I think that's like a bigger path, because I don't think this is generally safe to recommend on the internet. Okay, so that's kind of my view on this.
And the 08 came out like very recently, so I haven't had a chance to look at it closely. And
right, and that was one of the like points of feedback I gave Darren. Right, I said like, okay, like you're trying to push this on everybody. Like instead, like talk about like what you have done rather than like say like, hey, this should apply on the internet. So that's kind of the direction I'm okay with.
Eric Nordmark. Yeah, I mean, my comment is that before I read the draft, I didn't realize that there was this encapsulation going on, followed by the insertion, right? Because that actually changes it. And as far as I can tell, it's the way it's constructed, it's not going to leak any of these headers because of the encapsulation. So the actual boundary of the domain is well defined. I mean, it might actually leak the whole encapsulated packet, but then you have other problems, right? But it's not going to leak the fact that it just inserted a packet.
Suresh Krishnan. So like Eric, that was like one of the things that got removed in the SRH draft itself. So that was one of the points I brought up in the original SRH draft, which is now in the RFC at Q, and that got removed from the draft specifically for this reason. So yeah.
Okay, so Eric, and then I think we will wrap up.
Yeah, Eric, clarifying question for Suresh. So then, hypothetically, assuming things could get massaged into some acceptable state, is it hypothetically possible to publish both documents?
Yeah, that's what I was going to say. I think we should continue working on both of these.
Yeah,
And I think they can exist at the same time, and maybe we can get to the point of submitting them at the same time, but let's one step at a time.
Absolutely. Like personally, I think like it's both of them can exist and both of them have a spot. Like it's really, I don't think there's any conceptual misalignment between these two things, like to be very frank.
I don't disagree. I just wanted to get it down verbatim.
Let the minute taker know that these two documents can potentially exist together.
Yes. So good. I think we are done. We're 5 minutes late, but all in all, not too bad. And well, no, this was actually, we had 5 minutes at the front for us to talk, so you were fine. So I think this was a very constructive session. We are not done with this topic. So I think this wraps up 6-man in Singapore, and I guess we'll see you all in Vancouver. Yes. A shorter trip for me, but good. Thank you.
Oh, do you have blue sheets?
No, not yet.
So if anyone knows where the blue sheets are, can you please bring them forward? Thank you. Fantastic.
See, that's I have the other two, so you can give me those and I'll bring them all.